Hello, everybody, and welcome back to another funky, fresh episode of Maths. Hope you're all having a fantabulous day today, and we're gonna get a little freaky and do some fraction fusing. If that wasn't enough F's for you, then I don't know what is. So today we are going to be multiplying fractions. We've spent a lot of time learning about what fractions are, how to convert between different forms of fractions, how to add fractions, and also how to order fractions. That was kind of this previous section, and now we're heading on into the fourth section of the Fundamentals of Algebra series, so that's pretty exciting. We've done a lot, we've come a long way. I think this is like the 67th video that I've made on the series. So to start with talking about fraction multiplication, what we're going to do is let's just take a quick review on regular multiplication, specifically one of the perspectives on multiplication, the geometric perspective. Alright, so if I said something like, what is 2 times 4? Of course, we know that that is 8. But one way that we saw how to do this was if we took basically a rectangle and we said that there were, if we split the top up into 2 parts and we split the bottom up into 4 parts, then we can count how many squares we have in the rectangle, right? 1, 2, 3, 4, 5, 6, 7, 8. So this was another perspective that we had on multiplication where it was essentially just, multiplying the length by the width of a rectangle, and that helps us do multiplication. And it's also a super useful formula because it allows us to calculate the area of any square or any rectangle we see simply by doing the length times the width, right? So this was one perspective we had on multiplication, and it's actually this perspective that we're going to use when it comes to doing fraction multiplication. But I'm just going to make a slight modification on the visualization of this. The whole topic is going to be the exact same, but it's going to be a little more useful for the fractions. So what I'm going to do, in pink here, I'm going to draw a rectangle with 2 pieces, and down here I'm going to draw a rectangle with 4 pieces. And so what this is just meant to represent is this is the 2 and the 4 that we're multiplying to get this 8 pieces in our grid here. So it's the exact same idea, right? Basically, we just extend this line out and we extend all of these separating lines out. And we still get the 8 pieces that we started with. It's just now we're maybe a little more clearly showing the 2 numbers that we're actually starting with here, right? This is the 2 we're starting with, this is the 4 we're starting with. All right, so now let's get into multiplying fractions. So let's say I wanted to do something like a half times 3/4. So a half times 3/4. So what I'm going to do is I'm going to start by basically, kind of like what I had up here, just writing out the half and the 3/4. So to represent a half, I'm going to basically split this rectangle into 2 pieces and shade in one of those pieces. Right, so basically here, we've got a half, and then for the 3/4, I'm going to take a rectangle, split it into 4 pieces, and shade in 3 of them, right? We know this is a pretty standard way to visualize fractions. So we've got 3/4 right here. So now what I'm going to do is I'm going to basically allow these lines to continue again, just like I did before. And we essentially get 8 pieces again, right? So these 8 pieces, that comes from the 2 times 4, which is 8, right? So we're basically multiplying these denominators, right? So the denominators of 2 here and the 4 here basically tell us how many pieces that we have in total now when we're kind of multiplying these. But now what I'm going to do is I'm going to multiply these blue parts. And multiplying the blue parts, basically, well, we have kind of this 1 tall by this 3 wide. So multiplying all these blue parts, what we end up getting is kind of this smaller rectangle on the inside, which is just composed of 3 squares, right? But that is just 1 times 3. So essentially what we've done here is we've taken how many squares we have in total along kind of our 2 numbers we're multiplying, which is the denominators, and multiplied that to get 8. And then we took the amount of squares that were shaded in on each of these, basically the numerator of the fraction components, and then we multiplied those to get a sub-rectangle inside of the bigger rectangle, which has its dimensions of 1 by 3, which we found by doing 1 times 3. So essentially, a fraction problem kind of becomes 2 of these problems, right? The first one is by looking at the total number of squares we have and multiplying them, which gave us 8. And the second one is looking at the total number of shaded squares we have and multiplying them, which gave us 3. And so what we're going to end up getting then is that the result of this product is going to be the amount of blue, which is 3, out of the amount of total squares, which was 8. And what that ultimately corresponds to us doing is multiplying the numerators and multiplying the denominators. So multiplying fractions is as simple as that. So to multiply two fractions, you just multiply their numerators. 1 times 3 is 3, and you multiply their denominators. 2 times 4 is 8. So for example, 7/3 times 1/9, and we can even write this if we want, so we'll multiply the numerators, and then we'll multiply the denominators. So we have 7 times 1 is 7, 3 times 9 is 27. So 7/3 times 1/9 is 7/27. As another example, let's maybe do 2/9 times 1/4. All right, so that's going to be 2 times 1, just multiplying the numerators, and then 9 times 4, multiplying the denominators, which is going to give us 2/36. And this can be simplified actually into 1/18. So we still have to make sure to simplify our fractions as we go here. But multiplying fractions, in my opinion, is actually easier than adding fractions, right? We don't have to make a common denominator. We're just simply multiplying the tops and multiplying the bottoms and maybe doing a little simplification, but then we're good to go, right? But in terms of why fraction multiplication is the way it is, I want you to always be thinking about basically this geometric view where we're multiplying the denominators because that's how many kind of squares we have in total, and we're multiplying the numerators because that's telling us how many of the shaded squares we have, right? What's the area of the shaded squares that gets produced here? And just a little bit of terminology with multiplying fractions. If I have something like a half times 3/4, this is often read as a half of 3/4. So the term of here is used to denote multiplication. So if I said, what's 5/7 of 2/3, then that would be basically me saying 5/7 times 2/3, right? So 5/7 of 2/3 or 5/7 times 2/3. And because order of multiplication doesn't matter, right? 3 times 4 is the same as 4 times 3. This is the same thing as saying 2/3 times 5/7. So 5/7 of 2/3 is the same as 2/3 of 5/7. So just a little bit of terminology that I'll be using moving forward. So just be aware of that. Okay, so what if I wanted to multiply a whole number with a fraction? So let's say I wanted to do something like 3 times 2/41. So if you recall from previous videos, when we added whole numbers to fractions, we essentially just converted that whole number into a fraction. And we did that in a really easy way by just noting that the whole number is the same as it divided by 1, right? 3 is the same as 3 divided by 1, or 3/1. So now we actually have a nice fraction here, right? And we can do a fraction times a fraction. Once again, we just multiply the numerators, 3 times 2, and multiply the denominators. 1 times 41. So 3 times 2 is 6, 1 times 41 is 41, and this is our final answer here. Right, so multiplying whole numbers with fractions is pretty easy. There's just that added step of basically adding a extra denominator of over 1. But notice that if I did another one, let's say 5 times 7/2, okay, so I get 5/1 times 7/2. That's going to be 5 times 7 over 1 times 2, which is 35/2. Notice that every time I have a whole number times a fraction, essentially I'm always going to be getting that denominator of 1. And we know that anything times 1 is always going to be itself anyways, right? So instead of adding this extra step of doing 3/1 or 5/1, we can just simply do the whole number times the numerator, right? So if we had 3 times 2/41, we know that, yeah, we can make this into a denominator of 1, but 1 times 41 doesn't do anything in the denominator. So we can just do the whole number times the numerator, which is going to be 6/41. Just kind of jump right to it. Or for 5 times 7/2, again, we don't have to convert this into 5/1. We can just do 5 times 7, which is 35, divided by 2. And we get the same thing. So this is a bit of an unnecessary step, but this is ultimately why we're able to do this. So for computation stuff, yeah, you can just immediately skip to multiplying the whole number times the numerator. But keep in mind that what's actually going on is that you're converting it into a fraction out of 1. So if you ever start to get mixed up with, maybe you're doing whole numbers times fractions incorrectly, go back to doing this method until you feel good about it again, and then you can start using this faster technique. But if you start messing this up, that likely means you've forgotten actually what it means to multiply a whole number with a fraction. I've seen it a lot with students. This intermediate step might be worth it for a little while. How about mixed numbers? How can we multiply those? We see it's pretty easy with improper fractions, right? Because they have a numerator and denominator, no whole number part to worry about, so we just multiply those as normal. But for mixed numbers, well, if I had something like 5 1/3, and I multiplied it by 2 1/8, let's say, how would I go about this? Well, because it's so easy to multiply improper fractions, we're just going to basically convert these into improper fractions and then multiply them. We saw that that was a valid strategy for adding mixed numbers as well. If we do 5 times 3, which is 15, and add the 1, we're going to get 16/3. And 2 1/8, if we do 2 times the 8, which is 16, and add the 1, we get 17/8. So what we're going to end up getting then is 16/3 times 17/8, right? Just using basically their improper fraction equivalents. And then all we have to do is multiply the numerators and denominators. 16/17 might not be the easiest multiplication, so let's go ahead and do it. Right, so you get 272 on top. We get 24 on the bottom. Now this can be simplified, and you can check this. This can be simplified by dividing the numerator and denominator by 8 each, and we get 34/3. And since we started with mixed numbers, it's probably a good idea to convert this back into a mixed number. So we just do that by proceeding with some long division. So we get 11 1/3 is the result. So this is pretty much the best way to multiply a couple of mixed numbers. Basically just convert any of your mixed numbers into an improper fraction, and then it's go time from there. Now, there is another way to do it where we can avoid putting them in terms of improper fractions, but to really understand and appreciate that, you need a concept called distributivity, which is something that's going to be a little bit a ways away still. We still have some things to cover before we get to that, but for the time being, just stick with this strategy. And this kind of reflects what I've said in the past, how improper fractions are usually easier to do computations with than mixed numbers are, right? And here we're taking advantage of that fact by converting the mixed numbers into the improper fractions. So that's pretty much it with multiplying fractions. But before we go, I'm going to jump back to one of the applications we did in the previous section, which was on basically coins and fractions. So in that video, if I had something like, let's say, 7/4, I said, okay, well, I know a quarter is worth a fourth, right? It's a fourth of a dollar. So then I just immediately said, okay, well, I'm counting the amount of quarters I have. I have 7 quarters. But another way we can actually think about this is a quarter, right? A quarter of a dollar, like a single coin, that's worth 1/4. And to get 7 of them, yeah, we can just immediately jump to that numerator of 7 because we're counting how many we have here. But the other thing we could actually do is just do 7 times 1/4, right? Because we're taking 7 of this quantity of a quarter of a dollar, right? And when we do that, we just multiply the whole number by the numerator, and we get to the 7 quarters that we had in the video. So in the video, we were actually secretly doing fraction multiplication. We just didn't really know it at the time, and we didn't really need it necessarily, but this gives us kind of another perspective on what we're doing. So let's say I had 11 dimes. Well, I know a dime is worth 1/10 of a dollar, right? There's 10 dimes in $1. So if I do 11 times 1/10, I just can immediately jump to 11/10. So this is the same result as what we had in the video, but now we can kind of think about it in terms of fraction multiplication. So whenever I say I have a certain amount of quarters, I can just think about that amount multiplied by 1/4. If I have a certain amount of dimes, I can get that amount multiplied by 1/10. Same with nickels, right? Like let's say I had 14 nickels. So that means I'm doing 14 times, well, we know that a nickel is 1/20th of a dollar, right? There's 20 nickels in a dollar. So I'm really doing 14 times a 20th, which is 14/20, which I can simplify into 7/10. So 14 nickels is actually the same thing as 7 dimes, right? Because this we can write as 7 times 1/10. So we see that 14 of a 20th, or 14 nickels, is the same as 7 of a 10th, or 7 dimes, right? So fraction multiplication gives us kind of some extra perspectives on some of the things we've already been doing now. Of course, there's tons of applications for fraction multiplication. There's tons of reasons we need to know it, and it's going to be very useful moving forward. But I hope you kind of get a bit of an appreciation as to what fraction multiplication is in terms of the geometry we did at the start of the video, and also in terms of the fact that it's a pretty simple computation overall. But that's going to do it for me today. I'm going to see you in the next video where we're going to practice some of these concepts. Even if you found this easy, make sure you check it out because I always put in some pretty challenging problems in the exercise set, so it's worth your time. But until then, you have a good one, you stay groovy, and I'll see you in that next episode.
Nice. F.O.A. Maths.